Okay. Okay. You can hear, so let others join, but let us start. Let me just see if this is running. Okay. Okay. You can hear, so let others join, but let us start. Let me just see if this is okay. So we are ready. So let's today, as the course is structured, we have what have we seen so far? We have seen limits and functions limits, and used these to find the property of to find properties of functions using differential calculus. We used a definition of how a function changes by a derivative. So the derivative of a function we have defined how to see if a function is differentiable. We have also seen in the last class how the function, if a derivative is 0 at a particular point, it is critical point, and so on. So today what we'll do is, as the course is structured, so we'll be looking at all these concepts related to derivatives, and we'll be solving all the problems that were sort of somewhere in the assignment. Some are from outside, so 4 or 5 are from the assignment, 9 are from other outside. So that will give you an idea to how to use derivatives for various operations, for example finding critical points and doing problems related to Rolle's theorem and LMVT, and also plotting graphs using derivatives. So is the plan, is it okay? So
yes, sir.
Okay, let's start. So the first question, so this is one of your assignment questions. I thought it's simple, so let's start with this. So what is it saying? It's saying that, say you have a function g, right? So ax plus b by x square minus 1. So whenever you have a doubt, since today we'll be applying all the concepts that we learned, so if you have doubt at any moment, you stop me. And keep following all the steps. So I'll be doing see. So g of x we have defined. So solutions. So you have defined a function g of x, and you are telling why it has a local extrema at x is equal to 3, and it's saying g of 3 is equal to 1. This is one information it is given to you. And what is the second information it is given to you? The value of the function at 3 is 1 is given here. Now the second information is how will you use, so how many unknowns are there? So you're told to find a and b, right? So how many unknowns are there?
2 unknowns.
So how many equations do you need? You need 2 equations, right? So you have one equation here. So what will be the other equation for you?
We will first differentiate and then equals to 0, because local extremum is given.
So it's given, it's also a local extremum. So the derivative at 3 is 0. So let's solve this. So what we'll do is, these are the 2 equations that we'll be using. So if you have any doubt at any point, you stop me. So now let's just differentiate g of x. So you're going to use u by v rule, okay? By u by v rule that we have discussed. So by u by v rule, if there are any calculation mistakes, please stop me. I may make some mistakes, I'm trying to do fast, or intentionally make some mistakes to see whether you're following or not. So this is the derivative of the top into the bottom, into the derivative of into the upper function, that is u, and the derivative of the below function by x square minus 1 whole square, and you set it to 0, right? So this is your finding equation 2 that we have. So let's see what is this. So this is greater than, so x not is equal to 1, let's assume for the time being, and so we can remove the denominator since it is greater than 0 always. So we'll get ax square minus 1 minus ax plus b into 2x is equal to 0, which is nothing but equal to ax square minus of a minus 2ax square plus again minus 2bx, right? This is your derivative, g dash of x. Is this?
Yes.
Good. So let's see. Now g dash of 3 is said to be 0, right? So let's put the value 3 here in this equation. So you will have 9. So one thing you can subtract here. So you will get minus 2ax square or minus ax square minus 2bx minus a is equal to 0, or you can just put plus in all these, right? Since it is equal to 0. So multiply by minus 1 both sides and set x is equal to 3. So you will have 9a plus 6b plus a is equal to 0. This is one equation that we have. So this turns out to be 10a plus 6b equal to 0. This is equation 1 for us. Similarly, let's do a second equation. So the other equation will be g of 3 is equal to 1, right? Great. So we are seeing that g of 3 is equal to 1. So you can write, yeah. So g of 3 is for people who are joining late, we are solving ax plus b is equal to this function, and we have said that there is a local extremum and x equal to 3 and the value is 1. We are trying to find a and b. So g of 3 is equal to 3a plus b by 3 square minus 1, and that is said to be 1, right? So you have 3a plus, so you have 3a plus b is equal to 8. So these are the two equations that you have. You have you put at x is equal to 3 you have an extremum, and x is equal to 3 you put. So you have 3a plus b by 8 is equal to 1. So you solve these two equations, 10a plus, so you can do something like this. So multiply this equation by 6. So you will get 18a plus 6b equal to 48, and you have 10a plus 6b equal to 0, right? 1 and 2, right? You're following, right? You just,
Yes, sir.
okay, this goes to 0. So you have 8a is equal to 48, or a is equal to 6, right? So you have a equal to 6. That's let me just see if the answer is correct, because that would be depending on the others. So we'll, yes, that is correct. So a is 6 is correct. So a is 6. Then what is the what is the value of b then?
Minus 10.
Yeah, you just put it in this equation, right?
Yes. So I solved for b first and then I am solving for a.
So it's okay. It's not a problem. So you can get, so you'll get b is equal to minus 10. So this is this is just algebra that we did by using the concept that at a value 3 it is equal to 1 and the derivative is 0. This is the concept that we have used, and rest is algebra. Now what we'll do is, this is the question that is not given in the assignment. Okay, so what we'll do is let's do C first and then we'll do number 2. So for an question assignment, so what we'll do is we'll plot g of x and c. So we'll do that. Before that, let's see whether x is equal to 1 by 3 and 3, where do you have a local minima and local maxima, right? So let's do that. So let us continue. So part C we'll do first and then do B, because that's where many of you had problems last day, we will try and plot this curve today. So totally we'll have some time. Instead of doing at the end, we'll use derivatives to find out how the curve looks. So let's see. So you have gx is 6x minus 10, right? 6x minus 10 by x square minus 1. This is your function, right? Now it is told that where do you have a local minima and a maxima. So we have already seen that we have an equation like this, right? We have already found the derivative and found this is the derivative, right?
Yes, sir.
So we had found the derivative was equal to ax square plus 2bx plus a equal to 0. So we can directly use that, right? G dash of x is equal to ax square plus bx plus a is equal to 0. We can use this. I think this was the equation that we found. Yes. Now, what values did we find for a and b? A is 6 and b is equal to 10, right?
Yes, sir.
So we can write 6. So the derivative is 6x square plus 10x plus
Also minus 10.
minus b, na? Yeah, minus 10. So this is minus b is minus 10 plus 6 is equal to 0. So you can sort of minimize this equation, rationalize by dividing by 2. So you'll have 3x squared minus 5x, and you will have plus 3 is equal to 0. So do the middle term. You'll get 3x squared minus 3x minus 2. Is it right? Yeah, 2x plus 3. No, this is not what you'll do. 3 into 3 is 9. So 9 would be, and this is 5, right? So you would have 3 into 3, 3x. What mistake? So 9 is 3, right? So are we making some mistakes? So what was minus ax squared? This is equal to 3, 9, 27, 15. No, we did some mistake. Oh yeah, no. What mistake did we do? Oh, it's 2bx. Right? It's 2bx, not bx. We copied it wrongly. So it's minus 20x, right?
Yes, sir.
Yeah, so since we have calculations, there's a lot of calculations here. So please tell me if there is, I copy something wrong. So otherwise we'll lose a lot of time. So now you can do the derivative, right? So you can do the middle term. So it's 9x minus x, right? The middle term will be, so you can take 3x common, so you'll get x minus 3, and take 1 common, you'll get x minus 3 equal to 0. So x is equal to 1 by 3 comma 3, right? So these 2 points only they have given us minima maxima, right? They know that either of these 2 points will have a minima or a maxima. So now what should we do so these are your extrema points, right? Extrema points is the derivative is 0. So now what will we do? they have told you to classify 1 by 3 as a local minima and local maxima. So which of them is a local minima, which of them is a local maxima? What is the step that we will follow now? To categorize.
Second derivative.
So we have discussed last day, right? So if you take the second derivative, you will see the change in slope. So our maxima has a negative derivative because you would negative second derivative because you have the function is increasing before the maxima and then decreasing. Similarly, our minima also will have a positive derivative, second derivative. So let's see. So the second derivative will be g double dash x will be d dx of, what was the function that we have now? So we have the numerator is ax square plus 2bx plus a, right? So it's
Yes.
so we have also factored it. So let's write it as, I don't think it will be easy any helpful that way. So it's 3x square or 6x square minus 10x plus 6, right? by x square minus 1 squared, right? This is the function that we have. This is the first derivative, right? F dash x. So you look at this. This is the first derivative that we had found, right? This is the first derivative. So, and we had a minus outside, most probably, because I took a negative. So minus 3 we can keep outside and keep it as minus 3x squared minus 5 minus 10x plus 3. So what I did is, instead of writing, I just wrote this. Since it was 0, we had all these on the numerator to be negative. So you just you must remember this were all negative, and then I multiplied minus 1 before. So what I am doing here is, I'm just keeping it as it is. What am I doing? I'm just keeping this factor out. So let's take the derivative ddx of 3x square minus 10x plus 3 by x square minus 1 whole square. So you will have this as, or you could do one more thing, right? So this is let's see, we can, whether we need to take derivatives. So this g function g dash x can be written as 3x minus 1 and x minus 3 by x plus 1 or x square minus 1 squared. So you have something like this, right? We really don't need to take a derivative, because what we have here is, you have a number 1 by 3 and you have another number 3, right? So you have two of these numbers. So above 3, g of x, g prime of x is positive, and below it, it is negative. Between 1 by 3 and this, it is negative, right? G dash x. We had seen this. So x, if the value of x is greater than 3, we are sure that it will be positive, right? Because 3x minus 1, the numerator is, both the numbers are positive. If they are, we had seen, right? So 3 is the root, 1 by 3 is a root. Whenever we are going through a root, what happens is, the function changes sign, right? So it will change sign somewhere here. So at 3, g of x changes sign. So the derivative of the function, from an increasing function, it becomes a decreasing function. So somewhere in between, from somewhere in between 1 by 3 and 3, it will start increasing. And you also have a discontinuity at 1. So can you tell me which point will be a maxima and which will be a minima? This is very simple to see from the g prime of x graph. G prime of x negativity, right? So at 1 by 3 on the left hand side, so you always don't need to calculate what is the sign of the derivative. G dash x is greater than 0, right? And on the right hand side, g dash x is less than 0. Are you following me? If you have a doubt, you ask. So what I'm trying to do is not take a second derivative and still come up which is the maxima and minima.
So which right and which left?
So we are all clear about this, right? So what is the function that we have? So there may be a, let's write down the function first properly. Let's just do the first derivative once again and it will be like, we'll remember. So g of x was 6x minus 10, right? And divided by x square minus 1, right? So we're
Yes.
trying to do the derivative of this. So what is the derivative? The numerator will be 6, right? 6 into x square minus 1 minus your 6x minus 10 into 2x, right?
Yes, sir.
Into x square minus 1 squared. This is nothing but 6x square minus this. So minus 6x square minus 20x, or rather plus 20x minus 6, right? This is the derivative. So you take minus 3 common, you will get x minus 3x minus 1 and x minus 3, right? As we did before. We did
Yes.
the middle term, right? This is your g prime of x. So my question is, can we, without second derivative of this will be very calculative, right? And then you have to put minus 1 and all, and to see if it is a positive maxima or minima, right? It will
Yes.
be, it will be a lot of calculation. So I'm telling, from just from the derivative, can you infer if the function is a maxima or minima at what, 3 and 1 by 3? So in the first class we discussed how to see the sign of a function, right? Of a function that can be written as a factorial. So what are the roots of the function? 1 by 3 and 3. 1 and 3, right?
Yes, sir.
And the function is downward like this. Agreed?
Yes, sir.
Because at x is equal to infinity, all of these are positive, but you have a negative sign outside, right?
Yes.
So what we are trying to do is, I am saying, just from, so this is your g prime function, g prime of x, right? So you see on the left, so x less than 3 and x greater than 3, what is the sign of the function? What is the sign? So g dash of x is greater than 0, right? Here
Yes.
g of x is less than 0. What does it mean? And here similarly on the x 1 by 3, g dash of 1 by 3 is greater than 0, and this is g dash of 1 by 3, so not 1 by 3, is less than 0, right?
Yes, sir.
So what does it mean? So at 3, at 1 by 3, your g of x function, till 1 by 3 your g of x function was decreasing, right? So somehow, because your derivatives are negative, whenever you have a negative derivative, what does it mean? That your g of x function is decreasing,
Yes.
right?
Yes, sir.
And then it started increasing, right?
Yes.
So what does it mean? So that is a local minima. Understood? Yeah, it's okay. So did you understand how did we get that? So we are trying to discuss that just from the first derivative, can we able to find out whether the function is a derivative, whether the function is having a maxima at a point or a minima at a point, instead of doing the cumbersome second derivative tests. So at 1 by 3, did you understand why there will be a local minima? Because your function was decreasing up to 1 by 3, because you had negative derivatives, and then it started increasing, means, and at 1 by 3 it was 0, so it will be a negative, so it will have a minima there.
Yes, sir.
So 1 by 3 is a minima, and
3
similarly
is
maxima.
look, sir.
It is an absolute maxima. You can check. We will draw the graph. You will understand that it's an absolute maximum. We will see that. Right?
So why is 1 by 3 not absolute minimum?
So we'll see. It's just minima. Let's, for the time being, consider these as minima and maxima, not
Okay.
absolute. Okay.
Okay.
So they are local minima and local maxima. You understood that, right? So we did not do any second derivative test. So 1 by 3 was a minima and this is a maxima. And now let's plot the graph of this function. Then you will understand. Yeah, go ahead. Sharik.
No sir, continue sir.
Okay. Yeah, so I hope that, just a second. So I hope you understood that whenever you have a lot of calculation and able to find the graph of the derivative, so you're done. You don't need a second derivative test. I hope this will be helpful in many cases. just from first derivative. Now g of x we found as 6x minus 10 minus 6x squared minus 1, and g dash x is x minus 3x minus 1 and x minus 3 minus 3 by x squared minus 1. So g of x, so you see you have poles, right? I'll not go into poles very early. So what we'll do is, do you agree that at x is equal to infinity this function will go to 0?
Yes, sir.
Similarly, at x is equal to minus infinity it will also go to 0?
Yes.
Limit. So what did we discuss? So we discussed roots of gx, infinity, minus infinity. These are the points that we are important to draw a curve, and roots of g dash x. So let's see. So limit x tends to infinity, 6x minus 10 by x square minus 1. So divide everything by x square. So you will have, the numerator will become 6 by x minus 10 by x square, denominator is 1 by 1 minus x square. Just put limit x is equal to infinity, you will get 0 by 1, that is 0. That is a positive number, right? At infinity it is, the numerator is positive because x is positive. Similarly, at x is equal to minus infinity the numerator is negative, right? So you will have something like this, minus 0 and plus 0. Agreed? This is the type of graph you will have. Now, did you understand plus minus infinity?
Yes, sir.
Next is what we'll do is, we'll see the critical points, right? So we have found, and first we'll see the 0. At what point do you have a 0 of this function? 6x is equal to 10, right? So x is equal to 5 by 2, right? 5 by 3. Correct? At 5 by 3 g of x is 0?
Yes, sir.
So at 5 by 3, that is 1 point something, 1.67, that will become 0, right? Next, you have a pole at 1. Do you agree? What do I mean by a pole? 1 and minus 1 also.
Yes, sir.
Pole means your function diverges at x as it tends to minus 1 and 1. So you put 1, x plus 1 and x minus 1. So at x tends to very close values to 1, this will become tend to 0. And as this tends to minus 1, this will become 0. At minus 1, this is at 1. So you will have two poles. Poles, roots, infinity we have dealt with, right? Next, from minus infinity to 1 by 3 the function is having a negative slope. Do you agree? Which means it is a decreasing function, right? From the g dash x, this part g dash x is less than 0. Do you agree? Up to minus 3 it's less than 0, right? If you don't understand, you ask me now. This is a very important point. Now we have seen the function itself. Now you are going to the roots of the function. So the roots of the derivative. So what are the roots of the derivative? 1 by 3 and 3. But in below 1 by 3 that the derivative is negative, right? The derivative being negative means it's a decreasing function. Agreed?
Yes, sir.
So if it's a decreasing function, from 0 it will go to, and at minus 1 it's minus infinity. Do you agree to that? So it will keep on decreasing till minus infinity. Agreed?
Yes.
Similarly, it is also decreasing up to 1 by 3. But at x tends to minus 1, it's greater than minus 1. X is equal to minus 1. It is a positive number. See, g of minus 1 plus. So your numerator is negative, your denominator is also negative. Agreed? So it becomes a positive number. G of x. Agreed? So you have one more, 1 by 3. I think you did not understand this, what I claim. See, G of...
I understood the G of minus 1.
So G of minus 1, left of minus 1 is negative. You understood that, right? So you...
Yes.
Because this is positive. Minus 1 minus squared minus 1 is greater than 0. Do you agree?
Yes.
Because it's the absolute value of minus 1 minus is greater than 1. So if you take a square, it will be greater than 1. Similarly, if the number is on the right side of minus 1, so it's smaller than, absolute value is smaller than 1, right? So if you subtract 1 from it, the denominator will also become negative, right? So you have minus 1 right here. Say you have minus 1.5 and you have 0.5, right? Minus 0.5. So minus 0.5 squared minus 1 is less than 0. But minus 1.5 squared minus 1 is greater than 0, right?
Yes, sir.
Because x square is a symmetric function.
Yes, sir.
Similar, so you will have it will go to infinity like this. So it will go to positive infinity because both numerator and denominator are negative, right?
Yes, sir.
Numerator is also negative because both are negative, and it will decrease up to 1 by 3. At 1 by 3, whatever value it has, we have seen, it will decrease. And then from 1 by 3, we have an increasing slope. This is part 1 by 3 to 3, this is positive. So it will increase. Agreed?
Yes, sir.
And this is at 3. Last part, did you understand? I went a bit fast. Why did I draw it this way? So from 1 by 3, this is 1 by 3. At 1 by 3, you have a local
minima.
This is a local minima, right? You have a local minima at 1 by 3. So what does it mean? So in this 1 by 3, if you have a local minima, at 3 you have a maxima. We have already seen that, right? We have a
yes.
And similarly, you can check that for values x greater than 1, the denominator is positive, the numerator is negative. So this becomes a negative number, the denominator, right? Between 1 and minus 1 and 1, the denominator is negative. So negative is positive. At 5 by 3, the g of x changes sign, right? Before that it is negative. At 5 by 3, it's a root of g of x. Before that it is negative. Let's draw the sine curve of g of x also. 6x minus 10 x squared minus 1 squared, or minus 1, right? Right? So the denominator is x plus 1, x minus 1. For x greater than 5 by 3, is the function positive or negative? Somebody?
Positive.
Correct. So what did I explain in the first class? So whenever you have odd powers, the function changes sign at a root, right? Root or a pole. We had seen why it happens. Similarly, at 1, you have a positive power, it will change sign again. Understood? This is a sine function of g of x.
Yes, sir.
So less than minus 1, it's negative. Between 1 and 1, so that's what I have drawn. Between minus 1 and 1, it's positive. Between 1 and 5 by 3, it's negative. And then it's positive and has a maxima at this.
3.
And it's not the global maxima. Because you have global maxima is not defined for this function. This part, it goes to infinity. So whoever told it's a global maxima, it's not a global maxima. Right? This is the graph. So let's sort of plot it using Desmos and see whether we are correct or not. We have used mathematics and now we'll use the software and see. So what is the function? 6x minus x square. So I wanted to particularly
minus 1, no? 6x minus 10.
correct. Oh, 6x minus 10 divided by x squared minus c. Matching?
Yes, sir.
So wherever so this is both a local, this is a local maxima, your local maxima is lesser than your local minima. This can always happen. So this is a caveat. People can ask you trick questions. Can local maxima be less than global minima, local minima? So you can always say yes, right? Did you understand my claim? Your local, this is your local minima. This on here, on near 20, this point. This point. At 1 by 3. This is your local minima, but the value at local minima is greater than local maxima. Understood? I hope you understand. So what did we see? Somebody can you summarize? Am I audible? Yeah. So can you summarize what are the steps to draw a graph? So I have shown you the entire process to draw any graph. First, last day Mr. Pandey had a doubt how to draw a graph, but today I have given you the entire hands-on experience of entire graph, what to do. So what are the points that you need to see to draw a graph? What are the things that you need to understand? So I've noted it down here. So to draw a graph, yeah, go ahead. Go ahead.
So we first calculate the interval in which the function increase or decrease.
So first I told minus infinity, infinity, what you will get. Number 2, zeros and poles of the function. Right? Number 3, the derivative of the function. Derivative of the function, see zeros and poles of this. See sign, so understand increase by decrease, and zeros to understand minima, extrema of the function. That's all. Right? Good. So number 1, 3 questions are done. Let's do some short questions now and then go back to longer ones, right? So this was a very long question, took us 40 minutes. So I hope the message is clear. How to draw a curve, how to see the entire dynamics of the curve, everything is mentioned here. How to see extrema of a curve and curvatures also. You can see, if you want to see curvatures of a curve, you can see the second derivative test that we discussed before. So number 2 question is, let's copy it. So this says that great. So what does it say? A function f of x is given. You need to prove that a g of x has a root between 1 and 2. Any idea how we'll do it? Between 1 and 2. G of x has a root. How will you do it? Can you see a relation between, when you get this type of questions, what do you think should we go ahead and do? Any idea? So you see, is there a relation between these two functions f and g? So you see, f of 1 I'll put. F of 1 is log 2 sine of pi by 2 plus log 1, right? This is 0, this is 1, this is log 2. Similarly, f of 2 is log 2 sine of pi plus log 2. That is also log 2. So are you getting what is happening? So f of 1 equal to f of 2 and f is differentiable. So what theorem do you think we will use here? So one is this, we discussed this.
Rolle's theorem.
Correct. So we'll be using Rolle's theorem. And exactly how will we be using Rolle's theorem? We'll see. See, so you now understand that there exists a C between 1 and 2, right? Such that f dash C is equal to 0. Agreed?
Yes, sir.
This is Rolle's theorem, from Rolle's theorem. So whenever you see this, you must understand Rolle's theorem is what you're being asked. G of x you see is exactly f dash x. Just differentiate fx, you get log 2 cos pi x by 2 into pi by 2 plus 1 by x. Agreed? I'm taking the derivative of this function with respect to x. So f dash x is nothing but g of x. So g of x will have a root. So there exists a C such that g is 0. Hence proved, right? This is the trick you need to apply. So g is a derivative. So derivative will have a root wherever we will have a maxima of the function. Next, go to the next question. So an inverted isosceles triangle with one vertex at 0, 0 and 2 that meets the curve. So this is an optimization problem. Let's try. So it's an optimization problem. Number 3, it said something like this. Let's copy the diagram that I have drawn. This is 27 minus x square is y. Do you agree? 27 minus x square looks like this. It's an inverted parabola shifted up.
Yes, sir.
We have already seen minus x square, so it's we just shifted upwards adding 27. And this is your triangle, right? That is told. So this point, what is this point? Say this is x. So what is this value? So what is this coordinate? X comma 27 minus x square. Agreed? Yes or no?
Yes, sir.
So what is the area of the triangle now? So let us define A as, someone tell me, I'll not do this now. It's done almost. What is the area? So everything is known, base is known, height is known. Tell me, what is the area?
Half into 2x into 27 minus x square.
Correct. So this is your x. So this is your x again by isosceles triangle. And this height is 27 minus x square. So this turns out to be 27x minus x cube is your area. So what will we do now? You need maximum area. So how do you get the maximum area? You need to find the extremum of this, right? Extrema. Take the derivative. dA dx is 27 minus x square. d2a, I'll keep d2a x dx to minus 2x.
3x square.
Sorry.
There will be 3x square.
Yes, just calculation error. So this is your 0. So x is equal to 3, right? Plus minus 3. So you will have only, let's just consider, so it's plus minus 3, agreed?
So d square a by dx square will be minus 6.
Minus 6, yeah, just, that is true. I just wrote that time, did not write minus 3, that's why I forgot to write. So minus 6x. So we'll take only x is equal to 3 for the time being. We'll see why. So area is, what is the area? So area will be 27 into 3 minus 3 cube. That is 81 minus 27 equal to 54. Right?
Yes, sir.
Correct. So this is your maximum area, and how do I say it's the maximum area? You see, at x is equal to 3, this value is less than 0. X is equal to minus 3 does not make any sense since it's a length, right? So we are not, x is not equal to minus 3 because x is a length, right? Agreed? So this is the maximum. Any doubt?
No.
Mr. Pandey, I don't need it. Okay. Go ahead. Let's go ahead. These short questions now will go to a longer one. This is one of your questions that you came up in your assignment again. So 7x. So it's asked what are the critical points? Copy. Let's see. This is number 4. Number 4, question number A. What are the critical points? Let's keep the derivatives on the left hand side, it will be easier. So derivative is, so UV rule, what rule will we use? Use the UV rule. So what is the derivative? 11 minus 3x 1 by 3 plus 1 by 3 minus 3, 11 minus 3x minus 2 by 3 into 7 plus x. Agreed? 11 minus 3x 1 by 3 minus 11 minus 3x minus 2 by 3 7 plus x. Is it correct?
Yes, sir.
Yes.
So critical point, we will set it to 0, right? So we'll set 11 minus 3x 1 by 3. We'll take this some common things we can take, I think. X to the power 1 by 3, and we have minus 7 plus x. 11 minus 3x 2 by 3 is 0. So this is just taking the LCM. You'll get 11 minus 3x minus 7 plus x is equal to 0. Agreed? For x not is equal to okay, by it was done by another. So should I skip this? Others, so I can skip this, no problem. I have other questions as well. It will be easier. So it was, my name is Moinak, other person is Who did it? We can't hear you. Others, if you want me, I'll skip this question. Minus 2x.
Yes, I skip it.
Everyone agrees? So, even if one person is saying to do, so we can't. Okay. So anyway, so we'll let's do this. So we'll do it fast. There are other questions. This is just the, I thought it was a bit involved, so I tried to do it. So it's okay. Minus 4x is equal to 0. So x is equal to 1, right? So 1 and 11 by 3 are the critical points. So this is the, and 11 by 3 because your derivative is, you have a derivative here, inversion, so you will have that as wherever the gradient is 0, where the gradient does not happen. So this is, you agree that f dash x is not defined at 11 by 3. That's why that is also a critical point. Now this graph has two roots, right? At x is equal to minus 7 and x is equal to 11 by 3. Yeah, any question?
No, sir.
So and at x is equal to 1 you have an extrema, right?
Yes, sir.
Hopefully it's a maxima. Why? I can easily say that. So whatever he did, we will not use even second derivative test maybe. Just draw the graph, right? At x tends to infinity, it's negative, right? 11 minus 3x is less than 0, right? For x greater than 11 by 3. Agreed?
Yes, sir.
Correct. And similarly less than. So we can, using the same sign inversion formula. So we can say 1 is a, so we'll see, we did it very fast. So there are no finite maxima. This is true, right? So 1 is a local maxima, right? 1 is a local maxima as well as a global maxima, right?
Right.
Yes, sir.
So I don't think you will be using graphical methods in all the things. So we did it in 2 minutes. So it's okay. So in the number C part, let's just see what the value of f of x is at x is equal to 1, right? Just put x is equal to 1 here. That is 8 into 8 to the power 1 by 3. This is 16, right? So the maximum value is 16 and there is no finite local minima. Agreed? Minima is there. Minus infinities are the local minima, but we don't define, they're not informative to us, right? So we didn't even need the second derivative test. So try to refrain from the second derivative test when you have complicated functions by drawing the graphs. Understood?
Yes, sir.
Second derivative test can make it very complicated, very often. So now is this question. Now I'll see if someone can tell me how to do this. This is a question that will sort of give you a lot of understanding about how functions increase, decrease and so on. And you can see it algebraically. Let's do it. This is number 5. Or number 6 or number 5. Yeah, number 5. Any idea how we'll do it? You need to show that for all values of x greater than 0. So I will wait for 1 minute or 45 seconds. Can anyone give me the idea? Solution 1 and 2. We need to prove 2 inequalities, then we are done.
Maximum minima theorem of integration.
No.
We take
This is a differentiation class. So idea is using only differentiation we will do. So this is further on increasing decreasing functions. Let's consider this. This is a very important question to understand. So f of x, let's take this as f of x, right? This as g of x and this as L of x. Okay? So we define h1 of x as x minus x squared minus log 1 plus x. Can I define this? I am defining this way, just taking it this side. So what are the 2 inequalities you need to prove? This is the why am I doing this? I will explain. Right? This is one inequality you need to prove, and the other inequality you need to prove is 1 plus x is less than x minus x squared by 2 into x1 plus x, right?
Yes, sir.
Okay, so I'm just taking this on the left hand side. If I take this on the left hand side and show that this is always less than 0, that is also equivalent. That's why I will try to show that this is less than 0 to prove. Agreed? Let's consider Lx is equal to 0, h1 0, right? What is 0? At 0, what is the value of h1x? 0 minus 0 minus 0. Agreed?
Yes.
yes, sir.
Just all become 0. Log of 1 is 0. So it's 0. What does this mean? That means that h of x is 0 at 0. h1 of x is 0. This is h1 of x, right? Now if I can show that this function is decreasing for all x less than 1 or greater than 1, it will go to negative like this. If h1 of x dash is less than 0 for all x greater than 0, it will go to negative. Agreed? It has to be a decreasing function. This is my claim.
Yes, sir. Yes.
Correct. Others? If I am at 0, and I am decreasing, I will only go to negative, right? This is the idea.
Yes.
So if we can take the derivative and show that it is less than 0, we are done. So let's just take the derivative. So it's 1 minus x plus 1 plus 1 by x, right? So for x greater than 1, it is less than 0, we agree, right? Agreed? This is trivial because this is negative and this is less than half, rather let's see. Let's also do it for manually. Minus, right? So I wrote a mistake, made a mistake. This is the answer. So at x, now how, can you tell me if it is less than 0 or greater than 0 by just looking at this? I think we can. 1 minus x square minus 1 by 1 plus x, right? Is h dash of x?
Yes, sir. Yeah.
So what does it mean? Minus x square by 1 plus x, which is less than 0 for all x greater than 0, agreed? So the first inequality is proved.
Right, sir. Right.
Second inequality also we can prove in a similar way. Now someone will tell me how to do the second inequality. I will not do this. Second inequality I need to show is this one. I need to show, what function will I take? Suggest a function, which I go ahead.
X minus x square by 2, 1 plus x.
Yeah, Hedvi is going ahead. She started first, let her finish. Yeah, go ahead.
X minus x square by 2, 1 plus x minus ln 1 plus x greater than 0.
Okay, good. So minus log of 1 plus x. You want to show this is greater than 0, right? To show, this is to show. How will I show? First we have to show that this is at x is, what is h2 of 0? 0 minus 0 minus 0, right? That is 0, agreed? So now you have to show
yes.
The function is increasing, right? At 0 it is 0. Now you have to show it's increasing. So how will you show increasing? h2 of x is 1 minus into 2, right? This one, correct. 1 minus, let's do the differentiation. So 2x into 1 plus x minus x square into 2. If I make a mistake, please stop me in calculation. Agreed?
So plus 2x square.
Plus. Why? UV rule, right? So this is 2x into 2x square into derivative of 2 into 2 plus 2x. So this is negative only, right?
Achha, okay. Yes sir, got it.
So it's 2x, 2 will cancel with 4, x by 1 plus x whole square minus 1 by x. Let's take the LCM. 2 1 plus x squared minus x minus 1 minus x. So 2x squared plus 4x plus 2 minus x minus 1 minus x. This is 2 if I take 2x square plus 2x plus 1 . This is greater than 0 or not? We have done this last day. How do you define, how do you say that this is greater than 0? I claim that this is greater than 0 always.
Sir, because denominator is always positive and
numerator only. This is positive.
Numerator will be also positive because its d is less than 0.
Very
so
good.
Always.
So last day we said if the discriminant of a quadratic is greater than 0, is less than 0, it means no real roots, right?
Yes sir.
No real roots means does not cut the x-axis, and it is an upward facing. This is upward facing. Since that a is positive, so it will never go to negative, it will always stay positive. So the discriminant of this is d is 4 minus 8 is minus 4 less than 0. So this, since the discriminant is less than 0, the quadratic is always positive or above x-axis. So whenever you want to check if a quadratic is positive, you just take the discriminant. If discriminant is 0, then you have one root, always positive. If the quadratic is greater than 0, then you will have a cut. Because you remember Sridharacharya formula is this. So if your discriminant is positive, only then will your quadratic cut the x-axis. And if it is, and this is a greater than 0 also for the quadratic. If a is less than 0, you will have a negative, always negative, similarly. So that solves our question. So yeah, go ahead, Mr. Pandey. There is a connection issue from your side. You can try to do one thing. Try to switch off your video and then speak. It will help. Video is taking most of the bandwidth. You're not audio is not coming.
the axis.
Please switch off your video and then speak. Your voice is not audible. Yeah, so try to switch off your video. Your video is on, so that is taking most of your bandwidth. That's why your audio is not clear. Or type. Oh, you told to make it a perfect square. That is also okay. That is okay. But it's not required. Just discriminant checking is enough. You don't need even doing that. That is right. You can make it a perfect square and try. No problem. Okay. So let's do the next question. This is very interesting. So it's saying you have a curve of this form. Yeah, understood. Vertical sheet, that is correct. I understood what you are trying to do. Okay. Can you mute yourself? This is question number 6. So if a line joining the point 0, 3 and 5, minus 2 is a tangent to the curve y equal to ax, then which of the following is the correct value of a? So can you tell me what to do? So I have a curve like this, or whatever curve I have. I don't need to even plot it.
Sir, we will first differentiate the function and then find the slope using these 2 points and then compare, because y dash is equals to that slope. of the line.
Correct. Let's see. So, but here there are two unknowns. Do you agree that you need to find x as well, where it cuts the, where it is, the tangent is happening? That is not given to you, right? Right?
But that will get
Yes.
in terms of A, sir.
Yes, you will get two equations in terms of A. If you are having, either you can have one. Let's see. So, what is the slope of the line? It's -2 -3 by 5. That is -1, right? This is the slope. So we are trying to say dy dx at, say, x is equal to x0, where it is tangent. This is the x0 where you are cutting. This will be -1, right? This is one equation. So let's take the derivative. A into 1 minus x minus plus ax, right, is equal to -1. Or you have a and you put x naught here, so you can write a is equal to 1 minus x naught square. Agreed?
Yes, sir.
This is one equation. So for the second equation, what can you do? We can also do one thing, but that will keep it for the timing. So for the second equation, what should we do? What is the equation of the line? In our case, y minus 3 is equal to -1 into x, right? Y minus y0 into equal to mx minus x0. This is what I wrote. M is -1, y0 I am using this point. So it's 3 minus x. Y is equal to 3 minus x. Agreed? So at x0, this will happen. A x0 by 1 minus x0 equal to 3 minus x0.
Yes, sir.
So this is the line and this is the curve. Both will meet. There will be a solution at that point. This will give me the second equation. So if you have a doubt at this point, you ask. X is x naught square minus 4x naught plus 3. Yeah, it's correct. So your equation is x naught square minus 4 plus a x naught plus 3 is equal to 0. Agreed? So now what do you want to find? Which point do you want to find? You want to find a or x square, right? Both, either of these 2 points will do it for us. No, what did I do? So good. So how do you go about this? Just put this equation right in this. So this will work. Put the value of a here. X naught squared 4 minus 1 minus x naught squared x naught plus 3. Agreed? Substituting a. Solve for x naught. So this is, I'm expanding this one. Right? So this is 3. So x naught cube, or I can just put plus here, minus, plus, minus. So you have x naught cube minus x naught square minus 3x naught plus 3 is equal to 0. Can you tell me what is the solution to this problem?
X naught is equals to 1.
So we can do a factorization like this. So x naught is equal to 1 will solve this for us. So this is x minus 1. X naught is equal to 1. So if you put 1, so you will get 1 minus 1 minus 3 plus 3. Is it 1 or minus 1? I did some mistake. It's 1 only. It's okay. Okay. So f of x naught is equal to, so how do you factor this further? This is called the Chinese remainder theorem. You write whatever you have 3 times or n times in case of a nth root. So you know one root, right? You write it n times. So you will be left with a quadratic if you have a root. So this is the idea. So if you have a cubic equation, if you factor one root, you will be left with a quadratic. Agreed? Do you agree to this?
Yes, sir.
So any polynomial p of x can be written as a product of x minus alpha i's, where alpha i's are the root. So if I get one, I'll get the other. So how do you solve? So you need to get this back. So x naught minus 1, what do I multiply to get x cube? I multiply x square. So if I multiply x square, you will get x cube and you will get minus x square. Right? Now what else do I need to do? I need to multiply this with, so these two are done and these two are remaining. So if I multiply by minus 3, I will get these two and I don't need this term. In many cases you will be needing this term. For this question this is not required. Just doing this will help. So x naught plus root 3, x naught minus root 3, x naught minus 1 equal to 0 is a solution, right? So x naught equal to 1 is not a solution, right? X naught equal to 1 will not work, is not equal to 1. Why? See, y is disappearing and x naught equal to 1. Agreed?
Yes, sir.
So only answer you have is x naught is equal to plus minus 3. So that is what is A? A is minus of 1 minus plus minus 3. It remains plus minus, right? Minus of plus minus is also plus minus. I'm putting this here. So I get minus of 3 plus 1 plus minus 2 root 3, right? So you get minus 4 plus minus 2 root 3. Agreed? Last part of the calculation is clear? Negative,
Yes, sir.
negative with plus minus is always plus minus. So this is we'll also plot this and see if it is working. So x by 1 by x, so let's plot it. So what are the two functions that we have? We have y is equal to a, let's put this variable ax, we'll add a slider for ax by 1 minus x, and the other equation is y is equal to phi 3 minus x, right? This is one equation. So a, you see, has to be negative clearly for it to be tangent. See, how will I do it? See, So this is your, so I'm trying to adjust this value. So I'll put this value directly. What was our value? A, what did we find? Oh, ay is equal to a by 1 minus x. You add a slider for this, and then you will find a y is equal to 3 minus x. So what we found it to be 4 plus 2 root, or sqrt is the function, I think here, sqrt 3. Tangent, agreed? This is one tangent. Indeed, the line becomes a tangent to this curve.
Yes, sir.
And then you have 4 minus 2 root 3. Then it becomes tangent to the other side of the hyperbola. Understood? I hope it is very clear. Let's solve the other questions now. So this is the answer. Let's do next one, which is, now this is an interesting problem, very interesting. So you're saying water is poured into a vessel. We'll do it here so that we don't need to copy this equation. This is a small calculation, is very small for this equation, for this question. So water is being poured into an inverted conical flask. So let's think that this flask is your tank, right? This cone. Now we are going to some optimization problems, or this is not optimization, we have already, this is derivative, we have optimization we have done. So we'll see how to do this. So this is your cone, right, which is V, and the height is 12 feet or 12 inches, I think, or feet. So it's a huge tank. It's a 12 feet by 6 feet tank, and the radius is 6 feet, right? With the radius of base is 6 feet and height is 12 feet. At what rate is it rising? And the water is rising at V inch cube per minute. At what rate is rising at an instant when the depth is h? So water is being poured into an inverted conical flask at the rate V inch cube per meter cube at a rate. At what rate is it rising at an instant when depth of the water is h inches, right? So it is being poured at V inches per inches cube per minute, right? V inches per cubic per minute is how you're pouring water into this conical tank. So it's saying when the height is here, right? So this is your, say, effective height, h, right? And this is your capital H, and this is your capital R. So it's asking you dH dt is what? Is this the correct formulation? Have I understood the question correctly? It's telling what is the instantaneous speed of the rise of the height. It's telling instantaneous speed of rise of height, right?
Right, sir, right.
So it's dH by dt. So others, did you understand the formulation?
Yes, sir.
So it's trying. Yes, great. Let's go to the solution now. So how will you do it? So we know one thing, right? So it's given that dV dt is V, right? Let's dV dt is given to be, or should we write V? So per minute the volume is given to be V inches per meter cube, right? This is just a number that it is being said. So per time, what is the amount of volume that is increasing of water? That is right. This is
Yes,
given.
sir.
This is given to us. So I need dH dt. So what is the volume of the water? So volume of water, V water at, if the height is h at a particular time,
One by 3 pi r square h.
1 by 3 pi r when it is at height h square h, right? Correct? What is the radius? Radius will also change. How do you find this radius? Class 10 maths. It's a similar triangle, right? This triangle is similar. Agreed?
Yes. Yes.
So if it is a similar triangle, so you'll have 6 by 12 is equal to r by rh by h, right? So you will have h by 2 is equal to rh. Agreed?
Yes. Yes.
So this I will be just replacing. Pi r square can be replaced as h by 2 square into h, or this is 12 pi h cube, right? This is your volume as a function of h. Now I know volume as a function of h, but I need height as a function of h. Does anyone have an idea what should I do? Need is dH dt. I only know VH. So I know,
Differentiate with respect to t.
but this one, how can I differentiate with respect to t? Okay, you're that way. That's an intelligent answer. So you're telling me you differentiate with respect to t like this, right?
Yes.
So if you differentiate with respect to t, h has to be a function of t, right? Height is rising with some speed, right?
Yes, sir.
So 3 pi h square by 12 into dh dt. Agreed?
Yes, sir.
Okay. So what do I know from this equation which is known to me? This is known, right? This is V. See, there is some inches and feet cup issue here, but it will not affect us. Why? Because your dH dt and dV dt have the same, even if it is inches, your volume will manage that. So effectively we will not have a problem. We'll see what unit it turns out to be. So V is, so dV dt we have already seen. How is the volume increasing? That is V. So this is 4. So you have 4V by pi h. So this is your value dV dt. H square, right? Agreed?
Yes, sir.
This is your dH dt. What is the height increasing as a function of time? Now tell me, if this is dH dt, what is this value? What is the unit of this? Inches per minute or feet per minute? What is it? So V is inches cube per minute, right? Agreed?
Yes, sir. And height is inches square, so inch per minute.
How
will
is
be
height
the
in
answer.
square? So height is not in square.
Right.
So you have taken, it is inch per minute. On the right hand side, what do you have? On the right hand side, you have dH dt and wait. So this is your feet. H height is okay. H by 2. Just 1 second. So this is here. So h, all this h can have any unit of our choice. That is right. Correct. Correct. Okay. So these h can have any unit of our choice, right? There is no, it does not depend on feet or inches in our problem. Agreed? I hope this is clear. So if this can have any inch of anything as of our choice, so I choose these as inches. For example, if I choose height as inches, so I will have this as inch per minute. So anywhere, any of these I haven't specified inches or feet when I'm doing volume or dV/dt, right? I can always have any unit of our choice. This is my idea. Or this is, so how to convert to feet? Divide by 12, right? So this is 1 V by 3 pi h cube, h square, feet per minute. So why did I say we can have any choice? So this is the idea. So when we wrote the volume, there was no unit here. We could have put any unit. When we put the value of h, we'll later put, think in form of an inches instead of feet, because all we needed was the ratio, and height was a variable which any unit could be assigned later. Is that okay? Just in case, yeah. In case you are confused, maybe sometimes these things you may be confused the unit. So make your questioning as unitless as possible, and then put the units at the end, if it is possible, of course. If it is not, you can't. So this is the last next question. We have a few more left, 3 more left. So this is a very simple question. To make the question even simpler, what I did is, we have restricted the domain of the log scale between 0 and pi by 2, right? So it's telling in what interval between 0 and pi by 2 is this function increasing. So how do I do this? I take the derivative, right? I have said that the domain of the function is between 0 and the domain of log x is between 0 and pi by 2. So what is the domain of x between which this function increases? So how do I do? So this is defined only for log x between 0 and pi by 2. So to make the problem simple, so sine of log x is something like this, and cos of log x is something like this, right? So let's take the derivative and see. So I'm telling where is f of x increasing. So I'll take cos x log x by x minus or plus sin x log x by x. Agreed? So cos
Yes.
x. So you have here is cos log x has to be, to make some error over here. Is it minus? Just a second, let me see if I copied it correctly. Where is it? Log x, sin x, log x. I think we copied. Anyways, we'll do it for this one only. So cos x has to be greater than minus sin x. So it's always greater, so it's not useful. Let's put plus here. It will be easier to, if you have a plus, it will be having a better visualization. So if you have plus x, so this will turn out to be minus right? So you will have this as greater than 0, right? For the interval in which it increases, f dash x is cos x log x greater than sine of log x. So where does it increase? Where is it that is cos x is greater than sine x? Between which values? Between which values does this cos x is greater than sine x? So I'm trying to say
0 to pi by 4.
Right. So this is your sine x, this is your cos x. This is pi by 4, this is pi by 2. This is cos x, this is sine x. So between 0 to pi by 4, cos x is greater than sine x. Log x between 0 to pi by 4. So if log x is between 0 to pi by 4, our function fx is increasing, right? Otherwise it's decreasing. Agreed? So if log x is between 0 and pi by 4, what is x between 1 and e to the power pi by 4, right? Okay, any doubt?
No, sir.
Okay. So negative would have resulted in if the question that I had initially written was for a larger range. That would have, like, that is a trigonometry question, so it would not have been useful. If it was a negative value here, it would have been minus sine x, right? So minus sine x will always be lesser than cos x, so it was always true. Understood? Why did I change the question? If it was negative in between, so you would have for all x between 0 and pi by 2. That is the idea. That's why I sort of make it interesting. I tried this. Let's see the next question. The next question is the maximum value of the function x log x mod between x and between 0 and 1. How do I solve this? Very interesting, very easy question actually. Interesting is coming after this. So fx is said to be x log x, or natural logarithm of x. So between x is between 0 and 1, right? Correct? Next, so fx between 0 and 1, what is this? If I open the mod, what will be the value? Can anyone tell me?
X ln x.
No. Log x is less than 0 for x between 0 and 1, right? So x
Minus x ln x.
correct. So my x log x is less than 0 between 0 and 1.
Yes, sir, minus.
So you will add a minus, so to make it positive, minus log x. Just take derivative now and see, then we'll see the plot. F dash x is equal to minus log x minus 1, right? Equal to 0. So UV rule, I differentiate x, I get log x, I differentiate log x, I get 1 by x, 1 by x into x cancels to get 1. So I get x is equal to 1 by e, right? Yes. X is 1 by e, correct? Because I get log x is equal to minus 1 or x is equal to e to the power minus 1. So x is equal to 1 by e. F of x is 1 by e log 1 by e mod, which is 1 by e, correct? So 1 by e is the maximum value. So we can also take the second derivative test to see if it is a maxima. if double dash x is minus 1 over x, which is less than 0. So it's a maximum. For x greater than 0, it's a less than 0. So how will the graph look for the log x 1 by x function? Just for log x 1 by x, how does the graph look? At x tends to 0, you agree it is minus infinity? You have a root at somewhere, you have a maxima, right? 1 by e. You have a root at 1. At 1, this function goes to 0, right? Fx is equal to x log x. F of 1 is equal to 0. F of 1 is 0. F of 1 by e is, for log x, it's so x log x at x is equal to 0. Is it minus infinity or is some other value? Fx is equal to x log x limit x tends to 0. What is the limit of this curve?
0.
I think so, because see, it's a 0 by 0, so let's convert it into a 0 by 0 or infinity by infinity form. It's an infinity by infinity form, right? Correct? So we can what I'll use is I don't think we have covered L'Hopital's rule till now. L'Hopital's rule says that you can, if it is a 0 by 0 form, your limit is exactly same as the derivative of that at those points. So it's 1 by x 1 by minus x square. So it's minus x is your value, right? This is 0. So at x tends to 0, this value is 0. So this is, for this minima, you will have something like this. Hopefully, this is the you have, this is for your curve log x. This is x log x. If it is mod of x log x, this is this, right? Let's see if it is correct. So we will put where is the modular sign? X log x. Matching? So whoever's I think so, you will have to, when you have critical points, you will have to see these like this. So this is matching with our graph. At 0 that is not defined, after 0 it is matching, right? At 0 it's not defined, after 0 we showed that the limit is 0, and it's an increasing function that we saw, and it has a maxima at 1 over e, and then it decreases. At 1 there's a 0 followed by 1. Understood? Any doubt?
No, sir.
Correct. Okay. So let's look at this one, number 10. So number 10 says that you have 2 more questions. It will be two more short questions. It will be done then. So it says that your f of x is this. So we have to which of this following is true? It's an increasing function or a non-decreasing function or decreasing function, so on. So what is the problem we need to solve? F dash x we need to find. So f dash x is 2. What is the derivative of tan inverse x?
1 upon 1 plus x square.
So I had derived this on the first class when we derived. So what had we done? Tan inverse x we took as y, and we wrote tan y is equal to x, and then took dx dy as sec square y. So dy dx is 1 by sec square y, which is 1 plus tan square y, or 1 by, correct?
Yes, sir.
So we derived that. So 1 by 1 plus x square. Log x is
1 by x.
So x, what will be the derivative? Can you help me? 1 plus x square. Then the numerator is 1 plus
1 plus 1 by 2 under root 1 plus x square.
1 plus x square into x. 2 and 2 will cancel. So you have half here. Derivative of ddx of 1 plus x square is 1 by 2 1 plus x square into 2x. This is the one. You will have 2 minus 1 plus 1 by x square. The numerator will become exactly as the denominator, right? And you will have x plus 1 over x square by x into 1 over x plus, this is 2 minus 1 plus x square plus 1 by root over. Do you agree that this is always greater than 0? This is less than 1 and this is less than 1, right? So this sum, if you sum these two, it is less than 2, right? So if you subtract a number less than 2 from this, is greater than 0 if h is less than 2, correct?
Yes, sir. Yes.
So 1 by 1 plus x square is always less than 1 because it's something more than 1. So if you divide something more than 1, you always get less than 1. And this one also is something more denominator is something more than 1. So you have this function is, what is the inference that we draw if it is always greater than 0? Which of the following is right? Fx is increasing, fx is non-decreasing, fx is decreasing, fx is non-increasing. Which is correct? So we found
Both A and B.
fx is increasing. Non-decreasing is correct. Okay, but since you have, okay, it's also correct. This is also correct, but if it is single answer correct, then you have to choose only A. If it is a single answer correct, because it's increasing is correct, because it's always greater than 0. There is no equal to 0, so there is no question of staying same. So non-decreasing typically means there are some values in which the function stays constant, right?
Okay, sir.
Typically non-decreasing is something like this, but English wise both has to be correct if it is given. That is true. Next, number 11. The maximum value of fx is equal to 1 by x e to the power x square, 2x square. So number 11, last question. Maximum of y is equal to 1 over x. What is the question? 2x square, right? What is the maxima of this function? So how do I do this? Any idea? What should I do? Yeah. Go ahead.
Take log both sides.
Okay. So whenever you have exponents like this in x, try to take a log on both sides, and you have x here both. So you take log both sides, you get 2x square log of 1 over x, which is 2x square log x, right? Now take derivative on both sides, right? So you have dy dx into y inverse, agreed, is equal to minus 2x plus minus 2 log x, or rather 4x log x. Am I correct? So what I did is, when I differentiate the first one, I get minus 4x log x, and if I differentiate the second one, I get minus 2x into 1 by x, that is minus 2x. Correct, right? So you will have dy dx as y is always positive, do you agree? Because the power is always positive, it's defined only for x greater than 0. Not, it's defined for everything. Its power is positive, depends upon x. So it's always greater than 0. Agreed? There is no negative value here.
Yes, sir. Y is always positive.
Yeah.
Yes, sir. Even power.
Yeah. You can. There is some caveat, but it's still okay. Y can't be negative because your power is positive. So in some places this function has to be only defined over. There will be some caveat. So we will because for negative values, for odd powers, x square can still have decimal power. So decimal power also, I think you cannot have negative. So yeah, so it's not defined for only odd numbers, so it's only defined for positive numbers. Correct, it's only for positive. So y can be ignored. X2 minus 2 1 minus 2 log x, right, is 0. So these two I'm not taking to be 0. So x is equal to e to the power minus half, right? E to the power minus half. So you can get y as 1 by root e to the power 2 into e square, right? So 1 by e square. This is so I can take 2 inside, so I get e, right? E to the power minus 1 into 1 over e, right? So this turns out to be e to the power 1 by e. I think this is root e, right? e to the power 1 by e. I think negative is not there, so let's see once more. So x value is e to the power minus half. If x is e to the power minus half, what will be the value of y? E to the power minus half to the power 2 into e to the power minus half square, right? Oh, sorry, I made a mistake. It's 1 by x, right? That's why the answer was inverted. So 1 by x is 1 by e to the power this. Correct? This is your maximum value. Now just do the surds. So what it will be? E to the power of minus half means square root e, minus of minus squared to the power of e to the power of minus half into 2, right? So this is e to the power of e to the power minus 1. This is equal to e to the power 1 by e, or correct?
Yes, sir.
I hope this is. So if you saw the mistake, why didn't you, like, again we didn't put the values correctly? You should have told me. This is the answer. So and the last question for today is this. There's no calculation in this question, only understanding of the problem. Let's see what the question is about. So this is your number 12. We did 12 questions, very good. So 6 questions an hour. Good. So what is this? So it's saying that your g function, right, g of x is defined as fx minus f squared plus fx cube. And it said f of 1 is equal to 1, right? Great. Now what is the value of g of 1? It's told how many intersections are there between g2 e to the power, this is
1.
So is your answer 1 or is this 1? We need to find the intersection between g2 and g1, between 0 and 1. So you are saying this is 1, right?
G of 1 is 1.
Correct. So it's 1 is f of 1 minus f of 1 squared plus f of x is 1's cube. So this is 1, right? 1 minus 1 plus 1. Now we are told, so what do we know about g of x function, e to the power x square function between 0 and 1? This is something like this, right? At 1 it is e to the power, it is 1 by e. Correct? In our case 1 by e square. This is e to the power minus x square. This is the graph. And you need to only consider values between 0 and 1, right? This is this graph, okay? E to the power minus x square. So it's a symmetric
Yes,
graph
sir.
over x axis. So you flip over y. At 0 it's 1, at 1 it's 1 by e square. Now we are told, if we can say something about, we know g of 1 is 1, right? This is your g1 of 1. This is your g2. And this is your g1, right? g1 is 1. So if we can say something about increasing, decreasing properties of this function, we will be able to tell something about it. If it is increasing, we can say if it is increasing, there will be a point of intersection. right? If it is increasing from 0, there will be a point of intersection, right? Okay, let's see. So g dash x is what? Is f dash x minus 2 fx f dash x plus 3 fx f dash x. Agreed? This is the derivative of g.
Yes, sir.
Taking derivative of f, taking derivative of f square by chain rule is 2f into f derivative of f. So you take f dash common, you get 1 minus 2 fx plus 3 f square, right? This is said to be greater than 0. What is the second one? You see, second one is also greater than 0. See the discriminant. Discriminant is b square is 2, 4 minus 12 is less than 0. So this is less than 0, so this is also greater than 0, since you have a positive part in this squared part. So this is also greater than 0, so g dash x is greater than 0, right? Correct?
Yes, sir.
I forgot to mention one thing, so that will make it. So now we can see that the function is increasing, right? Always. It may not be like this, it may be like this also, right? This much information is given in the question, right? I know g of 1 is 1, right? And it is increasing on both sides. Agreed? Are you agreeing or not? This has to be the graph because you are fixing it so that it increases. Yes. If it increases, so it has to increase, it has to cut e to the power minus x square between 0 and 1 because it is increasing for all x. It will increase after x and it will decrease towards the negative value always, right? But there is a caveat. It is not always going to increase. So if I have an asymptote like this, then also it will always do that, right? Yeah, it will always do that because this value is between 0 and 1, right? This value is between 0 and 1 by e. So this is 1. So wherever you go to decrease, you always have to cut the curve, right? So one curve is like this. This is your g of x, g1 of x. That is decreasing like this. Right? This is your g1 of x. And g2 of x is said to decrease, always increase. So can you give me any curve that does not cut the other graph? This is a continuous function. It has to take, by intermediate value theorem, all the values between. There will be a x such that it will be equal to one of the points here, right? So is it clear? So you cannot have any other x such that it does not increase, it does not cut. You cannot have any curve because it is always an increasing function. It's a 1-1 function. So for all x, the next x is greater than the previous x, and it has to be at 1. So it has to, to go to 1, your x has to travel from all the way for x less than minus infinity, x greater than minus infinity to say point C. F of minus infinity says equal to C. I am not considering it as minus infinity. Say it's C, some asymptote, right? Or K. And at f of C, you have this value, right? So f of 1 is and g of 1 is 1. So by intermediate value theorem, your function must take every value between 1 to minus infinity. By an increasing value, there is always going to increase, right? Between k and 1, your function is going to take all values, right? Do you agree?
Yes, sir.
This is the intermediate value theorem, right? Between k and 1, all values will be taken. So g1 of x also has a value between these 2 points, k and 1. It will always have. I hope it is clear. So I'm not getting any response. So this is okay. So between these 2 points, yeah. You have a doubt? You want me?
No, it is perfectly right side.
Yes. So it will take all these values and then it must cut at a point. It will cut at only one point and not multiple points, because it's increasing function. It's a 1-1 function. So it cannot come back again and cut the curve. That's why we found it to be greater than 0. So it only has one point of intersection. 1 and exactly 1. See, so we having very general functions also, we would be able to understand how they behave if we are able to find the derivatives of those functions and manipulate those. So we solved all the questions of the assignments. We also did 8 questions outside the assignments that were related to all the theories that were discussed in differential calculus till now. So next time it's also going to be differential calculus, but we will be concentrating more on curvatures of graphs, which we did last time, but we'll do it more in detail for week 8. So I hope we don't have any doubt today. I was able to solve many of your doubts, how to solve questions regarding differential calculus, and so we'll be meeting next week. So if you have anything that you want to suggest, you can go ahead.
Thank you very much, sir. Thank you.
Yeah. So anyone else?
Sir, I have a problem.
Yeah.
Suppose there is a sphere, 3-dimensional sphere, and a plane is cutting it. In decimal, how can we see it? The point of intersection, etc.
Can we?
How to see the point of intersection? Suppose there is a sphere x square plus y square plus z square is equal to a square, and a plane is cutting it. X plus y plus z is equal to c, say. This kind of problems appear in when we solve the problems volume calculations.
So you will have a
Chapter 6.
So you will have a slice, right? I don't know about the
Yes,
book.
sir. Yes, sir.
So that's all you need to find. You need to find this equation by just solving this. So this is a simple geometry problem. You just need to
Yes, sir.
x plus lambda c. This is not a calculus problem exactly. It's a coordinate geometry problem.
Yes, sir. But in the book, they very beautiful pictures there are.
Yeah.
But
you can use
Thomas
calculus. I don't think it will
Thomas.
be. So you need to solve this way. So c plus lambda l. We need to solve this equation and get lambdas and all.
Sir, any software like Desmos for them?
I don't think you will be requiring this equation. So it's not in the scope of calculus. It's not covered. But anyways, you can see if you can solve. If you have any particular doubt, you can write a mail. We have anyway shoot over time. You can write to me, and I'll see if it is related or not. You can send me the exact what you want to know.
Sir, chapter 6.
Okay. You just send it to me. I think
sir.
You have my mail and all.
Sir, please give me the mail.
So my email is, I'll just share in the chat instead of.
Okay, sir.
Yeah. Yeah, so I have sent the email. You just write it to me. If it is anything valid, we will do it next day. No problem. because there's not much time. It's already 8:20.
Okay, thank you, sir.
Yeah. So we'll meet next week. If you just write the mail to me if you have a doubt. I'll try to solve it.
Okay, sir. Thank you.
Yeah, you're welcome. We'll see.
Thank you, sir.
We'll meet next week. Bye.
Thank you, sir.
Yeah. Thank you.
Bye.